I'll share my screen. Yeah. Can you see something? Can you see something?
I think it's not shared yet, sir.
Okay. Is it now shared?
Not yet, sir.
Not yet. Okay.
Do you want help from our staff to share? Oh, it's on.
It's on.
We can see your screen.
Oh, okay, okay. So it takes quite some time, right? So maybe some traffic jam somewhere. Anyhow, okay. Well, I've been introduced, yeah. So I don't think I need to reintroduce myself. I'm really thankful for the opportunity given for me to share something that I know. It's not much, but at least it's something that worthwhile to be shared. I'll be sharing on the practical aspect on the data science in chemical engineering because I'm informed that it's supposed to be like a chemical engineering like a domain or discipline to audiences. And I'm really thankful for the sharing by Mas Riandi before. He explained quite a lot on the data science and how they work, and then some applications in the oil and gas industries. And then some of the slides that he had, I have them as well in my slides. So it's coincidence. So that doesn't mean that I'm copying from him or he is copying from me. So that doesn't mean that way. It's just that that means we are thinking the same way. Yeah, we're thinking along the same line. I've been instructed as well. How long do I have here? Then I need to keep track of my time. Hello? Hello, hello. How long do I have?
30 minutes, sir.
30 minutes, yeah. Okay. So I've been informed as well by the committee that I'll pick like three people who are most active or ask good questions, so that these three people they will get prize or gifts from Schlumberger. Yeah, I'll pick three again. I'll pick three from the most active participants asking questions or whatever. So asking good questions so that they can get gifts from Schlumberger. You are free to ask any questions. Yeah, either you just stop me anytime, or you can just put your questions in the chat box and can discuss afterwards. Okay, so I think the outline will be what is data science. I think it has been explained in quite detail previously, so I will skip some of these. And then how do they work, the methodology, so I will skip as well some of these. But nonetheless, we'll just go through very quickly. And then the last, and then data science and chemical engineering, how do we perceive it? Do we have such course called data science and chemical engineering, basically? And then what are the required skill sets? What are the required skill sets if any of you would like to become like a data science so called? And then what do you need to expand from your toolbox of chemical engineering skills? And then the applications that I draw for myself from the last 15 years on the oil and gas refinery petrochemicals chemical industries. I'll skip myself. No, data science. Um, Before we talk about data science, we need to talk about the data, and it has been explained very well by Mas Riandi before. So just quickly, so we have lots of data as mentioned before, and then out of this data, we need to make sense of the data. So the first thing to do is then after gathering the data, all of these big chunks of data, useless, and then some chunks, and then some of it are useful, and we make some trends, we make some analysis, we make some calculations, and then from these trends analysis and calculations we can then further make any models or make some decisions based on that. Yeah, so we have the big data, and then we do some analysis, we remove some useless chunks data, and then we make decisions to move forward. So that's basically the idea of this big data and data analytics. So currently, I think now it's 5 Vs, but I'm not really sure. So it's this age is called big data age as well, because we have a huge volume of data coming in a variety of types, and the velocity where the data is coming is, if you I think you can Google how much YouTube videos uploaded every second, or how much web page uploaded every second. It's enormous. And then the rest is that the fourth V is then the veracity. This not all data are created equal. So like I said, some of these data are mostly junks. And why do these work? Yeah, I mean, how do these being applied? I think we all know there are a few public sectors already worldwide. So it starts from like, for example, yeah, this is I took it from this blog. So we have like a traveling, so we can predict the flight delay. You know, this Booking.com. You have also like this Traveloka and stuff. We have also like a marketing, so we can then predict who's going to be able to pay, who's going to be willing to pay like a more expensive, or a more unique product from Starbucks, for example. And then it can also mean like in social media nowadays, like LinkedIn, Twitter, Facebook, Instagram. So they can then they have within those companies, they have people working on what they call, um, I think like a attention engineer or something. So their job is then to get your attention as much as possible. So if you can then spend 24 hours of your life per day in front of the screen, that means they have done their job very much excellently. Um, it's also to the healthcare, sales, credit, and automation. So data are being used, and then data are being then analyzed, and then they can then make new products at certain time of the year, and then by having different kind of products, and then promoted and then sold at different time of the year, they are using these what we call this data analytics and then the artificial intelligence, so to say. So basically, they need to know from each of this business. They need to know, okay, so what is then the problem? Can we increase sales? Can we increase more productivity of the people, or can we increase their time spent on the screen? And then once they know what to solve, and then they can then ask themselves some questions like, okay, so how do we get the data? What kind of data we need? What kind of data they need? And then from this data, they can then make like a model, and then from this model they will then use this model, what we call later on this model, we're going to call them like machine learning model. And then this machine learning model are developed based on one of the techniques explained by Mas Randy before. So we get the data, they ask the questions, what is then the problem, what data we need, and then from this data they make some whatever that Mas Randy has explained before. They make the model and then use that model to make predictions, and then make like an optimize the situations. For example, if you want to increase the healthcare, if you want to increase the chance of having a high productivity, for example, and so on and so forth. I have a few, I think like a few minutes of video. It's good. I think we can just um, listen.
Are you one of the many who dreams of becoming a data scientist? Keep watching this video if you're passionate about data science, because we will tell you how does it really work under the hood. Emma is a data scientist. Let's see how a day in her life goes while she's working on a data science project. Well, it is very important to understand the business problem first. In her meeting with the clients, Emma asks relevant questions, understands and defines objectives for the problem that needs to be tackled. She is a curious soul who asks a lot of whys, one of the many traits of a good data scientist. Now, she gears up for data acquisition to gather and scrape data from multiple sources like web servers, logs, databases, APIs, and online repositories. Oh, it seems like finding the right data takes both time and effort. After the data is gathered comes data preparation. This step involves data cleaning and data transformation. Data cleaning is the most time-consuming process as it involves handling many complex scenarios. Here, Emma deals with inconsistent data types, misspelled attributes, missing values, duplicate values, and whatnot. Then, in data transformation, she modifies the data based on defined mapping rules. In her project, ETL tools like Talent and Informatica are used to perform complex transformations that helps the team to understand the data structure better. Then understanding what you actually can do with your data is very crucial. For that, Emma does exploratory data analysis. With the help of EDA, she defines and refines the selection of feature variables that will be used in the model development. But what if Emma skips this step? She might end up choosing the wrong variables, which will produce an inaccurate model. Thus, exploratory data analysis becomes the most important step. Now, she proceeds to the core activity of a data science project, which is data modeling. She repetitively applies diverse machine learning techniques like KNN, decision tree, naive Bayes to the data to identify the model that best fits the business requirement. She trains the models on the training dataset and tests them to select the best performing model. Emma prefers Python for modeling the data. However, it can also be done using R and SAS. Well, the trickiest part is not yet over: visualization and communication. Emma meets the clients again to communicate the business findings in a simple and effective manner to convince the stakeholders. She uses tools like Tableau, Power BI, and ClickView that can help her in creating powerful reports and dashboards. And then finally, she deploys and maintains the model. She tests the selected model in a pre-production environment before deploying it in the production environment, which is the best practice, right? After successfully deploying it, she uses reports and dashboards to get real-time analytics. Further, she also monitors and maintains the project's performance. Well, that's how Emma completes the data science project. We have seen the daily routine of a data scientist is a whole lot of fun, has a lot of interesting aspects, and comes with its own share of challenges. Now, let's see how data science is changing the world. Data science techniques along with genomic data provides a deeper understanding of genetic issues in reaction to particular drugs and diseases. Logistic companies like DHL, FedEx have discovered the best routes to ship, the best suited time to deliver, the best mode of transport to choose, thus leading to cost efficiency. With data science, it is possible to not only predict employee attrition, but to also understand the key variables that influence employee turnover. Also, the airline companies can now easily predict flight delay and notify the passengers beforehand to enhance their travel experience. Well, if you're wondering, there are various roles offered to a data scientist, like data analyst, machine learning engineer, deep learning engineer, data engineer, and of course, data scientist. The median base salaries of a data scientist can range from $95,000 to $165,000. So that was about the data science. Are you ready to be a data scientist?
So, that's it about the video. I think you get the point there, hopefully. So I summarize it into also another web page that I copied. So we need to understand the business, and then once we know what the problem really is, yeah, we need to understand what the problem really is, and then we go for the data, what data is required, and then we do some like a data cleaning, because some of these data and most of these data are junks. And then we do some what they call like a data exploration to see any trends and so on and so forth. And then they do like a feature engineering. So this all things is coming from the domains of computer science. So what they mean by feature engineering here is more like from this business understanding, we know what problems to be solved, and that problem is what we call like the y or dependent variable. Y or dependent variable, because in chemical engineering we are very accustomed to like this y equals to mx plus c, or y equals to f equals to fma. So that f or y is then the dependent variable, and then the x are independent variables. So this feature engineering is then to find what are the x, what are the independent variables that are important enough to control the y. Yeah? And then once we know what the x and then the y from here, and then we can then make the model. Is it y equals to mx plus c, or y equals to x squared, and so on and so forth, or y is also equal of a neural network model of the x, or decision tree model of the x, and so on and so forth. And then from once we get the model, and then we then make some sensitivity analysis or make some optimization, and then we can then present it to the customers. and then the cycle continues. So that's basically what these the activities really are. And then I think you've seen this. So it takes a little bit of many aspects of engineering. It takes we need to know a little bit on the method statistics, and then we need to know what is then the business, what is then being questioned now, and then some yeah some how do you call it, some skills in using the programming language or like a software using skill. I yeah, it's from Wikipedia again, to extract knowledge and insights from the data, and then once we get the knowledge, and then we can then apply this knowledge to make profitable decision. And I also copy this from the IBM data science course. I think it's from Coursera. So it's a process. Yeah, it's not an event. So it's the whole things that is going around this. So it's a process. It's not something that it can then happen in one day or 1 week. And then because we need to understand, this understanding takes some time, and then the whole of this data cleaning and so on and so forth, it takes another some percentage of the time, and then from these insights, and then we get the model, and then from that model we make like a strategic choice. It's about the study of the data. So that's basically what this data science really is. So how do they work? Yeah, it's also the I think it has been shared with you, Chris. It's basically the same. If I make this a kind of like about equal. I don't remember what this means in what the word for this in English. So the business understanding is more on this, the business understanding, and then to understand the data. So this whole data mining, cleaning, and data exploration is all about this data preparation and stuff. And then we make the modeling. So we make the modeling over here, and then we evaluate whether the model fits the data or not, and then we reiterate this whole stuff again until we can then get satisfying model, and then from this model we can then make informed decisions, so profitable decisions, and then we get then deployed into like a dashboard or something, which I will then show you. And in this part of the activity, because this then what is then being most taught in courses, and then if you go for data science courses in Coursera or EDX or whatnot, or in YouTube, they will then heavily bombard you with this, I think from here, yeah, from this part they will then give you all of this stuff, these techniques, but they rarely give you what needs to be done over here, because this is then the domain knowledge part. And then if you go further, collect data, the same thing, prepare data, and then divide the data, and then make a model, and then test, validate the model, and then deploy. So it's all iterative in nature. So this model, like I mentioned before, this is then typically in computer science domain, this is then typically referred to a machine learning model. Yeah, all kinds of models are there: linear model, non-linear model, neural network based, decision tree based, and so on and so forth. Yeah, there are many. But we are not supposed to be learning about all of them, because every day there are new type of model pops up, and then we don't need most of them. So now data science and chemical engineering. So what is this? Are we learning any data science and chemical engineering basically? I gathered together some articles which I think is very important. Latest one being here, the promise of artificial intelligence in chemical engineering. Is it here finally? So this is then the latest paper, not the, one of the latest papers, which I think is then very important one, because this professor, he has been working in the area of that artificial intelligence since early 80s, 1980s, yeah, 1980s, where he started to work on the expert decision. So it's about decision tree based process decision making. And then I think they are now thinking to incorporate the data science and the chemical engineering curriculum. I don't know about in Indonesia, but then in the US and in Canada and some part of the world, they are now trying to impart a little bit of data science activity in the chemical engineering curriculum. And then there's also another paper saying that we can then match this artificial intelligence and data science or non into chemical engineering domain, yeah, in like the monitoring, soft sensing, control, and optimization. I think you can read these papers. These papers are free. This one is free. This one is free. This one I'm not really sure, but I think it should be free. But if you read this and these two, that should be sufficient for you to understand. Is it something really new? Is it what is this actually? But then in 2018, I went to this conference in Philippines, and then I met this professor, and then he mentioned, he said in his presentation that he said, well, there's really nothing new here. All of these buzzwords and hype about data analytics, big data, AI, blah blah blah, these are all has been in chemical engineering domain since 1980s, which is in line with this professor. So we have been working in this data modeling, analysis, even in fact when neural network modeling approach came into being in 1990s, we have had included them into the into modeling of chemical processes, yeah, for process control and optimization. So there's nothing really new in regards of the data science and chemical engineering. So there is nothing for you or for us chemical engineers to be afraid of, to be like offended or whatnot. Um, so how do we work basically? So the typical workflow that I've been doing so far. So we have like a plant data. So I put this plant data, and then we also have like a process simulation here. I use Symmetry. Symmetry is the process simulation software owned by Schlumberger. So that's why yeah, you need to ask me questions so that you can get some gift from Schlumberger. Yeah, so either from the plant data or the process simulation, we can generate lots of data, and then this data we can then make model. We can then make model further, and then we can then apply this neural network or decision tree or like a simple linear and nonlinear and other type of model. And then from this model, we can then use this model to calculate, for example, profitability, yeah, a sustainability, like this global warming potential or the safety aspect. And then because we have profit, we have sustainability. We have profit, we have safety, we have environmentally friendly items. So it seems to be like a more objective functions to be met. And then this will then call, in the next step after we get this model, we will then use this to do like what we call multi-objective optimization, and then make or create some solutions of that. So this part, this multi-objective optimization is more like if you use Google Map. If you use Google Map, I think all of you have been using Google Map or whatnot. So if you want to move from a point A to point B, it will then show you at least two or three options. Will then show you at least two or three options. The first one being the quickest one. I mean, second one being the shortest route, maybe. It could also be the same route is then the quickest and then shortest route, depending on where you want to be and where you are originally located. So it gives you like three options in this case. So these three options are then three solutions that you can pick from based on your own preferences. Yeah, so that's what we call that's what's happening here. What's happening here, which is the multi-criteria decision making. So this part is not part of our chemical engineering curriculum, but it is there for us to be used. Yeah, so this is then the things that we've been using so far. So again, we have the data, we make model, and then this model can be combined with process simulation software, or we can just make independent model and then deploy it in Flask, like Master Yandy has mentioned before, and then we can make it in web page. So that's another thing. Or we can make a hybrid modeling with symmetry as well. And then from these models, either in web page or in hybrid modeling or in the process simulation software, we can then make use it to do optimization or multi-objective optimization, as I mentioned over here. And then from that, we can make profitable or sound decision making activity. So what are the skill sets that we need? Yeah. I will refer to you again on this because this diagram, it explains everything, I would say. You need to have like some knowledge and practical application for the math and statistics. Domain knowledge is very important, and then some yeah, programming skills. I think nowadays you guys, kids nowadays, they are born with programming skill, I would say. So and then you need to work on the math and statistics a little bit, and then for sure you need to improve yourself in the domains or the business knowledge on what you are working on. So number one, to embark on this journey, you need to be able to do yeah, you need to understand the process. How do we understand the process? Number one, we are taught to make process flow diagram, yeah, or what I call also here like a money balance. You make your own mass or money balance. make the first flow diagram or mind map, and then write down your line of thought. For sure, you need to make sure that you understand what is being questioned here. What is then the problem? So once we know what the problem really is, and then we need to understand what makes the problem. And from this, what makes the problem is that comes for another set of skills. So you need to understand. You need to be like a critical person in you. So you need to understand. You need to ask why, and then why, and then why, and then why, and then why, until you get the underlying principle of what make things happen. So this is an example of a pressure drop in a fixed bed reactor. So we start from here, and then the pressure drop keeps increasing because of the fouling. Only chemical engineering and only chemical engineering knows this. Yeah. So what constitutes the fouling? So it could be in this case the condensation of heavies on the surface of the catalyst. It will then block the pore of the catalyst. It will also then block the flow rates of the flow movement of the fluid. It will then increase the pressure drop. So that's what happens in here. One cycle, another cycle, and then another cycle, and then you can also ask yourself, okay, so this seems to be like a straight line for me. This seems to be like not really straight line. It goes a little bit curved, and then this one is there's a jump from here to there. So what is really happening? So this is something that you can ask the people from the plants. This is also something you have to ask yourself. So what happens over here is basically there's a water breakthrough in the plant, so that the catalyst is already damaged, and then they restarted the plant at already a very high pressure drop across the bed. So that's what happens over here, and then it is then linear, is it then the curve, and then from your chemical engineering knowledge, you know that the pressure drop across the fixed bed is governed by what we call ergon equations. So these are then the ergon equations. So we have the laminar part, it's a straight line, yeah? F to the flow rate, and then it's also the F square to the flow rate, the square of the flow rate. So this is then the laminar part, which makes it linear, and this is then the non-linear part, which makes this curve. So if you plot these equations on an Excel or whatnot, then you can see like a curvy graph. So let me explain what this is. So that's basically an example of how we need to be able to think the mechanism of the process. We need to think in first principle way. I think you need to watch the Elon Musk video where he emphasizes a lot on we need to think in first principle. And then you need to do also once we get the data, we know what the underlying process is, and then we need to understand if the data is correct or not, because most often than not, what we have in the plants, all of these transmitters, they are not maintained properly. So many of these data, they are junks basically. Yeah. So combining your sense of chemical engineering and then the knowledge of statistics, like I'm showing you here, you apply some common sense, and then you can then figure out, okay, so this data is not okay, that data is useless and junk. So and then you can then slowly but surely you can then clean the data and get a robust data set for you to then to work on to make a model. And this is also another analysis that I did. So we have a fouling tendency of a heat exchanger. So increasing the flow rate, it doesn't change the outlet temperature of the reboiler. But then somehow in this period we have there's a drop here. When we increase the flow rate on the x-axis, the outlet temperature drops already. And then this black dotted line is then black dotted line over here, over there, and over here. And then we can see this is a different period of time, and then as time goes by, we can see these dotted red dots, they are moving towards here. So here, moving towards here. So it shows the presence of fouling, where the outlet temperature of the reboiler cannot be met. Yeah, cannot be met. And then this part is an example as well. I have this, like for example, plant data, and then this then the example. So this then the corresponding simulation that I made. So if you can then make run some sensitivity analysis, we can then know the effect of one x to the y, and then we make a plot, and then we can then compare is the data on the field makes sense or not. Yeah, the data on the field makes sense or not. So in this case, if I increase the x, and then the y seems to be increasing, so and then I compare it with our chemical engineering domain, and it seems to be the case. So I can say that this data is okay. But then this data is somewhat very strange, yeah. So it acts like this. While I would expect that to be if we increase the x, the y would also increase in this manner. So this data is something that we have to be really careful. Is this data correct? And then how was this obtained? And then what can we do and what can we learn? So all of these questions, we need to write them down and then ask them on the field. Most likely people on the field, they are not aware of this. So it's then our job then to be able to explain what is then happening over here. So the same goes like here. It's a very straight line. It's also a straight line. It's a very straight line downwards. It's also a straight line downwards, and so on and so forth. So this is then the way how we make, how we do, or how we apply some common sense into analyzing the data. So once we get the clean data set from here, we can then leave it to the to your programming skills. So we need to understand the process, and then we make the algorithm. So make some calculations. So it's something that equation that you have to derive yourself on the field, and then based on this equation that you derive yourself on the field, and then we can then make the code and then do some calculations and then deploy it for the operators to see. I think it's all high level and then a lot. So the only thing is that you need to be always be courageous, work systematically, and then you have to be able to communicate effectively. Yeah, I put all of these pictures, nice pictures together. First and foremost, we need to be open mind as well. Yeah, we need to be open mind as well, and then we need to know that we don't know much of everything. Yeah, we don't know much of everything, so it means we need to be always open to our mind and keep asking questions. Obviously we have to be asking them very politely, and then we need to because we don't know much of everything, so we need to talk to different people of knowledge. Yeah, if we don't know something, we have to talk to people of knowledge. We have to ask questions and then get their inputs, and then from their inputs and then the knowledge that we have to make our own understanding clear, and then we try to communicate that, and then is this the one that you explained for me? So this is then what I think it is based on the data that I have and the knowledge that I have. Does it seem to be making sense to you, and so on and so forth? Yeah, this is something like this process, asking and then questions and then receiving answers and then communicated back, it's all embedded in all of these data science, so-called data science applications. And then if all these parties agree, they know, so these then are problems, and then we can then make a plan and then work on the plan accordingly. And then you always need to be transparent with the team and then the stakeholders, people that we are communicating with in this project. So all of these are soft skills. Previously, all of these are hard skills of data and chemical engineering. So these are more on soft skill. So I think for most people, these soft skills needs years to masters, and then for some, it's also like comes naturally. But I think for all of us, we just need to be keep on practicing. And the applications, I think I've how much more? I don't know. Yeah, I will spend like 5 minutes here. So so I did it here in 2009, 2010. So I was working in this company called Respa, and then they need to maximize the build up of the plant, the product, sorry, the product, so that they can then pass this European fire test. And then so what needs to be done? What needs to be done here? So I make a from the data. So I make a model, and then I then play around with this X variable. So what resin we need, what type of resin, how many layers, and so on and so forth. So in such a way that I can from the data that we have, we know for sure what the outcome would be, and then the optimum outcome or the optimum build up that gets to the best outcome, we can then put it into productions to be produced. Basically, that's what that this is. And then in 2013, I was working on the we need to make a mixture that can melt. So we have several chemicals, and then and some of these chemicals, they have different melting points, and I get the data, and then use partial linear square modeling to get to make the model, so that we know which chemicals that can be mixed with the which chemicals, obviously, to get the melting point that we want. So from that data, from this data, so the new mixture, I'm not going to tell you what new mixture is. So I predict it to be will be having melting point of 56 plus and minus 2 degrees C. And then they run the experiment. And then they obtained that the melting point of the new fit mixture is about 55 degrees C. So that 55 degrees C is 56 plus or minus 2 degrees C. So this knowledge and skill is very, very valuable. The one of the latest one is that we have different projects, and then each project they come with their own capex and opex requirement, also the time duration that they need to complete. Then my job is that obviously we apply what we call heat integration or page analysis, and then in this case we financial page, and then I make some algorithms from the mathematics, and then we can then optimize it using linear programming, and then visualize it using Power BI in this particular case, so that people can then see all of the projects on one dashboard, and then they can look, okay, so these 1 2 3 are the projects that we need because they are using less amount of money, less capex, and then they can then bring back more money, higher NPV in this particular case. And then this is the symmetry, if you are aware. So I make this symmetry model, and then make the machine learning model, and then use that machine learning model to get me an ideal target. So this is then the ideal target where we can then achieve water dew point in a way that we can then reduce the riboidity. So these two are basically the current operating window, and these are then the targets. So we can see that we can reduce to get to the same water dew point of the gas. We can then reduce half of the riboidity. This is also about the chemical process equipment, where this is basically a DME plant, DME plant where we dehydrate methanol into DME, and the DME is taken over here. These two distillation columns are very difficult. Well, not very, it's because it's recycled. It's also very difficult to converge. Not easy, yeah, not very difficult, but it's not easy to converge. And then I replace this equipment, one equipment, and these two equipment. I replace it with the machine learning model. This is then that, this is that. So these machine learning models, these two, combine it with the first principle calculations in chemical engineering, because we know there's a reactor, heater, exchanger, pumps, and tanks, and so on and so forth. So this first principle model will take time to converge, while this is very quick. And for quick decision making, we can then better use this model instead of the original one. There's also like a machine learning model to play around with the what if scenarios, where we can predict what is then the rate vapor pressure of a condensate by playing around with some of these flow rate and temperature operating conditions of the units. This is also like a performance monitoring, because we can then get the plant's data, put it into like a visualization tool, in this case the Power BI, so that they can see how do we perform today. So this, for example, the duty of this exchanger is supposed to be this is then the minimum value, this is then the maximum value, and then we can see they are all below the minimum value. So that means this particular unit is not performing as designed. And then this is another dashboard. Another dashboard to compare. This is basically the same like what I've put over here. It's just that instead of only 2 data points, we get the whole operating duration for 3 years. So this is the whole operating duration for 3 years. This is the ideal target. So where we are here somewhere, and then this is the target. So what we need to do is then we can then play around. We can then open this valve, and that valve increase this reservoir, and so on and so forth, in such a way that we can then move from here to there. So at least with these visualizations, they know where to go and what to do. In the end, if we have too many dashboards, so this is also a joke in data science. So if we have too many dashboards, so I'll do dashboards. So this is then the project manager, so to say. So this project manager is only doing his job for the sake of KPI. So he doesn't really understand what he is doing. So he says our new dashboard has all the different KPIs that we can track now. So this guy, maybe you, and then he says that, well, what is this then? Is that KPI turning to 0? And then he obviously says that, well, it measures how well we understand them all. So that means we basically don't understand any of this thing. So so to let you go, so I will then say to you that first and foremost, you need to understand the problem. We need to get your questions right. Take home messages from this. You or us, we need to strengthen our domain knowledge. In this particular case, it's a chemical engineer or process engineer, because we are that's what we study. So So we need to be able to use that knowledge in the first place. And then we also whenever we are faced with problems, we need to be able to think in first principle, and then we also need to ask always the right questions. And then because technologies are coming, we need to always learn and improve ourselves to technologies. It's all overwhelming. I can see. There's also there are many techniques here, as mentioned by Mas Rian. There are many techniques. I'm not expecting you to understand them all, to be able to do them all, because that's not your job. Your job is then to strengthen your domain knowledge, to understand the problem, and then you can then simply Google how to do this in Google. Yeah. So start small, and then but continuously, and then wherever you are, whatever you do later on, you all have to work with your heart always, and then never stop learning. Yeah, work with your heart, because it will then bring you good quality, and then people see quality in you, and then you need to be able to increase your skills every now and then. So with that, thank you. Do we have any questions? Hmm, how do I see questions? Uh, hmm. My name is Fauzan. Yeah, hi, Fauzan. Nice to know you. Okay. No, all the time. Uh, um, yeah, sama-sama. Um, I would like to ask about how we divide the role for a data science project. Divide the role. Is being data science makes us have to know all the data processing step, or we can divide the role to optimize each other role. It's a package, my friend. So you cannot be a chef by only you know how to cook, right? I'm assuming that you know how to cook, being a chef. So I don't think you can call yourself a cook or a chef if you know only how to chop some onions. No, it doesn't work that way. So if you want to consider yourself, I'm a good cook, or I'm a cook of I can cook nasi goreng, for example. That means you need to know what you need for your nasi goreng, and then what ingredients you need to have, how to prepare those ingredients. Yeah, you need to know how to chop the onions and stuff, and the whatever, and then you need to know how much ketchup and sambal, and then how much rice, and then to be put to make a nice nasi goreng, and then you need to know how to prepare that nasi goreng itself, and then to make it, and then you can add some skills in visualizations or food photography, so to say. Then you can say yourself a data scientist. This type of project is not as quick as making nasi goreng, obviously. So it will take weeks and months. Yeah, it will take weeks and months. Yeah. So if you have like your project design project and nowadays you can undergraduate, it will take the same roughly depending on the complexity of the project. It can take like 2 or 3 months at minimum, and then maybe half a year or 1 year or whatnot. So it depends on the complexity. It will take time. It will take time. And obviously, if you say, for example, yeah, yeah, when you say, now, I have this, for example, you could also say, now we want to make a whole plant, a model of the whole plant, and then you can then say, okay, I can only, because limiting the limited time that we have in the project, I can only help with this column. So that means you can then divide yourself. So you are doing this, and then your other colleagues will do the other part of the project. That can be done, but the whole steps. In my humble opinion, you before you can say yourself a chef, you need to know how to cook from start till the end. How do you know the data we choose is right for our problems? Yeah, exactly. I've been telling you. So number one, use your common sense. Yeah, you have your domain knowledge. You need to be able to understand what is really happening. You need to ask yourself questions of why. Why do you have this problem? Why this problem has this effect, and how this X contributes to the Y, and so on and so forth. So once you know this, and then you will then know what data you need. Yeah, and then the quality of the data, and then it will then comes to you naturally what type of quality of data that that you need. So I can only answer this in qualitative way because you need to have a practice to this. Yeah, same way if you ask me something about process design or plan design, then I can only say to you qualitatively. To be able to answer you in quantitative manner, and then means you have to ask me quantitatively as well. One is defined is that can indeed be solved, but cannot be modeled in mathematics. And then how to solve this one? Hmm. If we find the case that can be solved using machine learning but cannot be modeled in mathematics, I don't understand what you mean here because machine learning is mathematics by definitions. Because ML is very close to mathematics. Yeah, right? So you answer yourself here. So how to solve this problem? There is no problem because this is then what you have answered. Machine learning is mathematics by definition. And then how to solve this problem? There is no problem. Whether using data driven or another. So if you have data on this selection column, for example, and then you can use that data to make a machine learning model, and then you plug in symmetry, and then you have your own plant models. Yeah, if you don't have it, and then you can then simply run case studies here, generate as much data as possible. As much data as possible is something that you have to figure out yourself. Yeah, it will take another one semester to discuss this, and it will take another few hours courses to know how much data is needed, and then is that the data that we need. So it is going to be like case to case basis. Yeah. What I can say to you is that understand your process, know your domain knowledge, and then combining the first principle way of thinking with the process understanding, and then you will know what data you need. You will know. Yeah. How to validate the model? Well, I think you know how to validate the model because it has to be based on your common sense. It has to be based on the first principle knowledge that you know. For example, a distillation column, we have a reflux. Yeah? In this column, we have a reflux. So the question is then, if this reflux goes up, what happens to the concentrations of the distillate? Any answer? Uh, okay. My questions to all of you: if we increase the reflux of the distillation column, what happens to the concentrations of the distillate stream? So anybody can answer that will get the gift from Slamberger. I'll give you like 1 minute to answer. And just type in the chat, yeah, and then I know. Uh, Hi guys, this is chemical engineering second year course, distillation column, and I'm assuming all of you are older than the second year. I don't know if you are younger than second year of chemical engineering. Yeah, my apology, but we can always try. Yeah. So questions again. Until 12:30. Yeah. If I increase the reflux ratio, if I increase the reflux to the column, what happens to the concentrations of the distillate stream? So that's basically the question. So I'm waiting 12:31 for the answer to pop up here. Concentration of distillate will be decreased. No, no. Okay. Yeah. If I say no, that means you know what the answer is. But Olin, thank you for your answer. Even though you don't get it right, but I will give you a gift from Schlumberger. So I think the committee can note down the name of this person. Um, yeah, I know. So yeah, so that's one to be a gift to be given, and then to Olin, even though it's a wrong answer, I think we can also give Resa, yeah, because it's good questions that you ask, but it's a bit mixed here and there, but okay, it's all okay. Um, okay, any other questions that you can ask me? You need to ask me, yeah, because if you don't ask me, that means I don't know what you understand, and then I will then assume that you know what I know. So that's a very error assumption that I can make. Um, Any other questions? How much time do I have left? Yeah. So I have still one gift to give. Still one gift to give. Yeah. Not me. Sambaje will give you a gift. So one gift goes to Olin. Another gift goes to Reza, and then one more gift. So any questions for me? Well, always ask questions. Yeah, forget you can forget about the right questions, but yeah, you always need to ask questions. Um, what are the crucial things that people often ignore when studying data science? Yeah, I think um, when studying data science, in my experience, this is not magic. Yeah? So all of this data science, before 2010, before 2010, I've been working on this stuff since 2008, 9. So before that period, before 2010, we call this statistical analysis and statistical regressions. So all of these linear, non-linear, neural network, decision tree, all of these are just statistical regressions. So and this is not magic. So what comes in, it means it's the same like in all modeling. If we have like a garbage in and then you will then get garbage out, so understanding what kind of garbage that you put into your data analysis, that's very crucial. So how to know whether we put garbage or we put gold in it? So the only way to know, from my perspective, is that you need to understand your domain knowledge. You need to know what is the why, which is then the business problem. So what do we need to do? What is then the problem? So once we know what the problem really is, and then we can then make a mind map, or we can ask 5 questions, or we can do like a fishbone diagram. So to cut the problems into pieces so that we can know what are the underlying principles behind that problem. So we need to be able to know what are the X. So if this plant, for example, we have this distillation columns, for example. So if we want to increase the purity of the distillates, so what do we need to do? So it means we need to wash it more, yeah, because you need to have, if you need to have like a clean clothes, you need to wash it more. In distillation column, how to wash it? You need to put more reflux to get pure clothes. Yeah. So if you need to put more reflux, that means you need to know. Okay. So if I want to put more reflux, I need to be able to know. I need to be able to open the valves. So when I open the valves, the reflux goes up. So then you go to the plant, and then you can see that valve. Is the valve stuck? Is the reading around that reflux flow rate is correct or not? So all of these things are things that you or we know beforehand based on our domain knowledge, and this is then the crucial part from my experience. You can always disagree with me, but at least that's what I know. And then the understanding this phenomena, and then then okay, so that means to increase the concentrations of the distillate, I need to know the temperature of the condenser. I need to know the flow rate of the reflux. I need to know the flow rate into the column, and also the flow rate of the distillates, and so on and so forth. And then you can then make your calculations using process simulation, or you can also use your own calculation in Excel, and then try to figure out whether the data that you get on the field, do they make sense or not. Yeah. Is that clear, Rara? If that is not clear, Rara, you can always ask me again. And then as an addition, I hope there are more courses of data science with the data science. Yeah, right. You are, and then I assume you are a woman. Um, I hope there are more courses of data science. Yeah, yes, there will be. So stay tuned with Slumber. Yeah, with I think Mas Guntur. I think Reza knows Mas Guntur. So we will do more data science course in engineering. Yeah, because that's what I will be sharing with you. I don't really care about this compliance marketing and whatnot. So so we do the engineering part. How common is the valve stiction issue happens in the industry? It happens every day, my friend. So I think I have answered your questions. Yeah, how common happens every day? Because well, all of these mechanics, because this is mechanics. Yeah, all these mechanics, it can wear and tear. All mechanics can wear and tear. Yeah, that's why we need to do maintenance in our car, maintenance for our on the chain of our bicycle, maintenance on the valve, obviously. So if we don't do this maintenance, yeah, then you will see a problem. Yeah, we will see problems if we don't do maintenance. If you don't maintain yourself, for example, you eat a lot but you don't exercise, you don't take a nice good night's sleep, and then you can see what happens in your body. So please do maintenance always. And then what happens in the field is that people assume that some part of the equipments they are not very important, so we don't do that maintenance a lot. So without any knowledge. So making assumptions without any knowledge is very dangerous. So from that perspective, we need to be able to make a map of what needs to be done, what is then the problem that we need to solve, and then we cut them into pieces so that we know what the underlying principles behind it, and then we know what are the X or the independent variables that we need to take care, and then this X or independent variables that we need to take care, we need to maintain the quality of the data from that. For example, this reflux ratio. So this reflux is then I don't know, just take a stupid example. So this reflux is then controlled by the control valve. Yeah. So we know that this reflux ratio is important to ensure the quality of the distillates. So that means we need to be able to make sure that that control valve, that reflux control valve, it has to work accordingly. It has to work accordingly. It doesn't stick. It doesn't stick. So that's an example. The same goes with process safety, for example. And then if you want to make sure that the safety or the reliability of the process safety valve, for example, we need to discuss with the vendors. We need to know do like a proper maintenance. We need to check because it has to be able to run whenever it is needed. So we need to do this maintenance. We need to increase the reliability of the equipment. Um, yeah, I think I've answered you, Yam. If not, then let me know. Just put another questions in the chat. Um, I think I can give the last gift of Slambaje to Rara. Yeah. And then I've shared three gifts of Slambaje with you. But nonetheless, do you have any other questions? If you can always ask me questions, yeah, you know where to find me. You can just Google me, and then you can find me, and then ask me questions. Um, any other stuff that you would want to discuss?
Sir, I'm sorry. Unfortunately, we have to end the Q&A session here
Fine.
due to limited time.
Fine with me.
Okay. Okay, so thank you for all the participants who already asked on the Q&A session. On the next session, we'll have the session for handing over certificate to Mr. Zulfan.
Okay, firstly, hello Mas Zulfan, and thank you for Mas Zulfan for your insight and presentation today, for taking time and give us an opportunity to discuss, and very good and understandable. Yeah. Your presentation give us a new knowledge and give us a helicopter view about application data science in chemical engineering. So I'll also apologize if there is technical errors during the event. Please accept this certificate of appreciation from us as a sign of gratitude to Mas Zulfan.
Yeah, thanks.
I hope.
Thanks.
Yeah, I hope we can collaborate again in the next time, Mas.
Yeah, no worry.
Yeah.
Thank you.
Maybe we can check a photo to Amare.
Okay, maybe I will count. 1, 2, 3. Once more. 1, 2, 3.
Yeah.
Thank you.
Thank you, Mas Zulfan.
Thank you. Yeah. Bye.
Okay, so the second session with Mr. Zulfan is over. Thank you very much once again, Mr. Zulfan, for the knowledge